Hello students, welcome to week 2 of Mathematical Theory of Interest course. So in today's lecture we will continue our discussion from last day of the first week. We were discussing about the equations of values and yield rate. So in the previous class we discussed how we can calculate the time value of money of different kinds of cash flows. We discussed how to calculate the present value and the future value of lump sum amount, how we can calculate the present value and the future value of an annuity. In annuity we discussed there are 4 different kinds of annuity: ordinary annuity, annuity due, deferred annuity and perpetuity. We have calculated, we have practiced and calculated the future values of ordinary annuity, annuity due and deferred annuity. So in today's class we will continue our discussion where we have stopped in last session. So here we are supposed to calculate the present value of the money. In the previous class we have calculated the future values. So here we will calculate the present value of money. While calculating the present value of money, first of all we need to understand what is the present value of money. It is the process of discounting future cash flows of money to obtain its value at a zero time period, or we can say that at current or today's time period or at present time period. Present value actually tells you the amount you must invest today to accumulate a certain amount at some future time period. To determine the present value, we need to know the amount of money to be received in future, the interest rate to be earned on your deposit, and the number of time period. 3 things we know: the future value, the interest rate and the time period. Now here is the little difference between discounting and compounding. We need to understand the difference between discounting and compounding. I will give you a very simple example. Compounding is the process of calculating the future value is called the compounding, and process of calculating the present value is called discounting. The same interest that we use to calculate the future value is called the interest rate, and is called the compound interest or interest rate, and the rate at which we calculate the present values is called the discount rate. Now here we will calculate the present values. As we know that how we can calculate the present value of future cash flows, we will just rearrange the future value formula. After rearranging the future value formula, the new formula for present value will be present value is equal to future value divided by 1 plus r raised to power n. Here PV is the present value, FV is the future value, R is the rate of discount, and N is actually the time period. We can also use the table formula to calculate the present value of annuity or simple present value. There are 5 different cash flows as we discussed previously: lump sum amount, cash flow stream, annuities, growing annuities and perpetuities. We discussed in the previous class. So first of all, single cash flows. If we have only one cash flow, how we can calculate the present value? We will use simply this formula to calculate the present value of this amount. Suppose you would like to accumulate $50,000 in 5 years by making a single investment today. You believe you can achieve a return from your investment at the rate of 8 years. Now we are supposed to calculate the present value. We want to know how much we need to invest today to achieve our goal. What is our goal? We want 50,000 at the end of 5 years. That is the future value. R is 8% and time or N is 5 years. N is 5. So we will put all these values. We can calculate the present value interest factor by using this table. At 5 years and at 5%, at 8% and 5 years, that present value interest factor from this table, the value of present value interest factor is 0.681, and we will multiply with 50,000 and finally we can get this result 34,050. We can use this table, this simple manual formula, future value divided by 1 plus I raised power 1 plus r raised power n. By using this formula, the answer is 34,029.16. We can get almost similar kinds of results. This difference is ignorable. Now second one is the valuing, calculating the value of a stream of cash flows. If we have multiple cash flows during the future time period, then we need to discount all these cash flows, and finally we will we will just take the sum of all these values, all future cash flows present value, that will give us the answer of present value of total cash flow stream. For the first value we will discount it, for the second value, for third value, fourth value, so on till the nth value. We will calculate separately their present values by using the present value formula, and then finally we will just add up all these present values to calculate the total present value of this cash flow stream. This formula can also be used, same formula can also be used to calculate the present value of annuity and present value of unequal cash flows. But for perpetuity we use different concept, because in case of a perpetuity the payments are made till unlimited time period. Now here is an example. From this example you can see that at the end of first year you are getting 1,000, at the end of second year you are getting 2,000, at the end of third year you are getting 3,000. So we will calculate the present value of each cash separately and then add up all three cash flows present value together to find out the total present value at the start of zero time period, or at the start of this cash flow stream. Here is how you can calculate the total present value. You can use the formula, you can use this table, you can use any format. This is just for your understanding. The answer will be same. You can even use the table to calculate that will be more easy for you. Now here is the third one, annuities. In annuities we know that we get equal payments after equal intervals for a specific time period. There are two kinds of annuities: annuity, ordinary annuity, and annuity due. These are most important. There are two other types of annuities. Later on we will discuss. These are deferred annuity and perpetuity. Again we can use the previous method to calculate the total present value, but because the payments are same, we can simplify our formula to calculate the total present value. To calculate the total, this is the simplified formula to calculate the present value of the future cash flow streams of an annuity. This is how we can the bottom one and the previous the top one, both method are these are the traditional method, or you can say that the simple discounting methods to calculate the present value. But instead of using this complex calculation, because this is just 5 cash flows, imagine if there are like 20 cash flows or 50 cash flows, then it will become time consuming activity for you. That is why we calculate present value of equity by using the formula. This is the very simple formula to calculate the present value of annuity. By using this formula we can easily calculate the present value of this ordinary annuity. In case of annuity due, the payments are made at the start of the period. So the for the first cash flows we don't need to calculate its present value. For the rest of the cash flows we need to calculate their present value. This is the difference between 5 period annuity due and ordinary annuity. Ordinary annuity is called the regular annuity as well. For that cash flows, for that we need to add up one extra cash flow, which is the zero cash flow. Here is how we can calculate we can use the present value of annuity due. Next one is the deferred annuity. In deferred annuity, remember the payments are not made for a specific time period, and the payments actually starts after certain time period. From this question you can see for the first two years no payments are made. The payments has been started from the third year. but we are asked to calculate the present value at 0 time period. So what we need to do, we will just assume it as an ordinary annuity starting from third year. At the end of third year, we assume third year is the first year of ordinary annuity. So we will calculate the present value of this ordinary annuity that will give us the answer at the end of second year. For the from first year 0, from the second year till 0 time period, we will just simply discount it, compound discount it to calculate the present value of deferred annuity. Present value of deferred annuity. This is the formula to calculate the present value of deferred annuity. The first part is basically there are two ways to calculate the present value of deferred annuity. The second one part, the second method is most commonly used, that I have already explained to you. The first part refer to the annuity part. The second part in the bottom formula, it is referred to the compound in discount factor for deferred time period. Compound discount factor for deferred time period. Now moving further, this is how we can calculate the second part, starting from where we have actually started our annuity. So first of all, we will calculate the PV2, then we will calculate PV0. PV2, payment at present value at the end of second year. This is the first part of the formula. In the second part, we will further discount it for further 2 years. This is how you can make your calculation to calculate the present value of a deferred annuity. We can also calculate, instead of combining these formulas, we can just calculate separate calculations. We will just make our calculations separately. First of all, we will calculate PV2, and then secondly we will calculate PV0. For uneven cash flows, maybe we can't calculate the present value by using the annuity formula. So it totally depends upon this situation. Maybe it is a mix. For certain time period it's an annuity, for other time period it may be we have different cash flows. We will use both concept, same compounding method as well as lump sum cash flow method, as well as annuity method, just like the previous example. We will just simply discount each value separately, and then we will add up all these present values together to get the total present value of uneven cash flows. This is example 2. Present value of a growing annuity, or we can say that it's a present value of a perpetuity. This is the formula to calculate the present value of a growing annuity, in which the rate of interest is growing every year. This is a very simple formula to calculate. Here we will use this formula. The growth rate is less than the discount rate. We are assuming two things. These are the two assumptions. The above formula can be used when the growth rate is less than R. If it is greater than R, then we can't use this formula. Now moving further, here is an example of this present value of a growing annuity. You can easily understand. Last one is the present value of a perpetuity. Remember, present value of a perpetuity is basically the type of annuity in which the payments are made for infinity time period. Normally in case of life insurance we use this formula, or pension funds we use this formula. Cash flows multiplied by present value of annuity, but simply we are assuming that it is going for unlimited time period, so that its interest factor is 1 by R, 1 divided by R. We will just simply multiply with cash flows to calculate the present value of annuity, perpetuity. So this is all about our today's lecture. I hope you have understand all the concepts to calculate the present value of lump sum amount, present value of mixed cash flow stream, present value of annuities. In present value of annuities, we have 5 different kinds of annuities. Present value of ordinary annuity, present value of annuity due, present value of a growing annuity, present value of uneven cash flows, and present value of perpetuity. Present value of perpetuity. So if you have any question, you can ask me anytime. Just send me a message and I will reply you as soon as possible. Thank you so much. Bye bye. See you in the next class.